Hello everyone. In this session, we are going to discuss about the dataset and DataLoader classes within PyTorch. So we are also going to discuss about how you create a custom dataset class and try to define the way in which we need to access the data by using a couple of methods called getItem as well as alien. So DataLoader class here is going to leverage these two different methods heavily in order to actually understand the way in which we need to access the data and also get to know the total number of samples that are present within your actual dataset so that it can prepare or it can read the number of samples associated with every batch within the mini batch gradient descent optimization process that you are conducting. Okay. So data loader is going to help us retrieve the data in the way in which we need to access the data, in the way in which we plan to access the data. So that's the essence of using dataset and data loader classes here. So we are now going to create a custom dataset class. Create a custom dataset class now. So before we actually read the complete housing price data, we'll actually look at what data we have used for creating the linear regression model in one of our previous sessions. So in one of our previous sessions, we only have used a sample data in order to create the model. We have somewhere around 6 different observations and 3 different columns or variables that we have considered for the overall train data here. And we have 6 different observations that are defined for your target variable as well. So whatever observations or data that we have taken is fairly limited. So with this fairly limited data, we have arrived at a loss value or an MSE value of close to about 48. And we also have understood the predictions and actual Y values are pretty close to each other. Now let's consider reading the complete data and trying to implement this particular linear regression model by using PyTorch built-ins. Okay, for that we need to create a custom dataset class first. So let me define a class and call it as custom dataset. And within this particular parenthesis, let me use this as a parent class. Dataset class is going to act as a parent class. And now I'm going to inherit all the attributes and methods associated with this particular class called dataset class. So we already have this getItem as well as alien methods that are available in dataset. We are going to override those methods because we need to define the way in which we need to access the data. And we also would need to inform PyTorch the number of samples that we are having so that it will compute the necessary number of samples it would take for one single iteration there. Okay. So now let's define the init method first. So init method generally has this self, and self.x is what we need to create, and self.y is also what we need to create. But along with that, we'll also try to assign the total number of samples that are present within the dataset. Now, I'm trying to read the data. I'm just trying to read the data, which is placed in the form of a CSV file in a given folder within my drive. Okay, in a given subdirectory within my drive folder. So I'm trying to access my drive folder by using drive/my drive. And I have a subdirectory called files. Now let me check the name of this particular file. The name of the file is bostonhousing.csv. So now I read the data completely. So once I read the data, I only need to consider the X variables here. And I need to consider a NumPy array before I convert the NumPy array into a PyTorch object. So X and Y here are nothing but PyTorch objects. So we always need to create tensors here. So when I say PyTorch object, it is nothing but tensor object. So X and Y here has to be tensor objects. But the data is available to us in the form of a data frame. Now let me write a simple list comprehension here so as to retrieve only the X variables. So call for call in data.columns, just trying to read all the columns of all the columns that are existing within this particular data set. Which of these columns is not MEDV, which is a target variable? Here MEDV is nothing but the target variable. Let me write this separately so we are clear about this. MEDV is target variable, which is nothing but median value of house expressed in terms of thousands of dollars. Cool. So the remaining all variables can be considered as X variables here. So now since we have the data available to us, let me convert this to a NumPy array. So once I convert this to a NumPy array, I simply make use of this particular function called from NumPy, which actually converts my NumPy array into a tensor object. Done. In a similar fashion, we'll also now read this particular Y data And let me also convert this to a numpy array. Once I convert this to a numpy array, torch.tensor or torch.numpy is going to help me convert this particular numpy array data into a torch tensor object. Okay. I'll also reshape this particular data into the total number of samples that are present within the dataset, comma 1. If you observe carefully, earlier we basically have reshaped the y data, which was one-dimensional in nature, in two-dimensional tensor. 6 here was the number of observations that are present within your data, which is nothing but length of x if it was a data frame. If it was a data frame, then you're trying to retrieve the number of rows or number of observations by making use of this particular function called len. So similarly, now since this was a data frame, I just have provided len of data so as to understand into how many number of observations or records do I need to present my data into. Obviously, there is only one column because y data is only referring to a particular column called MEDV. So the total number of samples here is again going to be length of this particular data frame. So we now have defined the init method. Let's also define the getItem method. So getItem method is going to help us define the way in which we need to access this particular data. I'm always trying to return a specific observation of my X data. So when I'm saying specific observation, it has to be an index. So self.x subscripted with index and self.y subscripted with index is what I'll return into. So DataLoader is going to invoke this particular method multiple times so as to retrieve the data. So here we have defined the way in which we need to access the data now. It has to be x comma y. Depending on the number of samples that you are considering for each batch, you will return those many number of observations within each of your tensors x and y. Okay. So once you have implemented getItem, we'll also implement len method. I'm defining self method within the parenthesis, self object within the parenthesis here again. So return self.nSamples, which is already tied to the object itself. If you look at this particular init constructor carefully, we already have assigned the total number of observations that are present within your dataset to attribute called nSamples. I'm just making use of the same attribute here and returning it. So whenever DataLoader inspects this len function, it now totally understands how many number of samples are there in total. It clearly knows, given the batch size, how many number of iterations that it needs to conduct for the optimization process. Now let me run this whole code. Try to create an object specific to this particular class called custom dataset. Call it as dataset object. So once I have the dataset object, so here there's a problem stating that name read is not defined. So it should be pd.read_csv. Let me rerun the whole code. Now recreate this particular object. Now we have this particular object defined. So I am going to create an instance of this class called DataLoader now because I would want to load the data one at a time. So I am providing this dataset object that I have created in the previous step. Dataset is equal to dataset. Sorry about that. So dataset is equal to dataset, and then I'm also providing the batch size. I'm defining the batch size as 10 and shuffle is equal to true. Okay. So this I'm calling it as DataLoader. So once I have the DataLoader object created, I can also create an iterator object, calling it as data_iter. Iter function within the parentheses, I'm providing DataLoader object. So whenever I am going to use next function, I am going to retrieve the data, retrieve a particular batch with a batch size of 10. That itself is indicating that there will be 10 different observations within this particular tensor, referencing the tensor x. So x has got 10 different observations. Similarly, y here has got 10 different observations again. So as many number of times you are running this particular statement, it's going to retrieve the subsequent data sets. So it will retrieve the subsequent batch now if I'm running it again. It's going to retrieve the next batch. It's not same as that of the previous one. If you look at this particular first value, it's 1.358. So once I rerun this statement, it's no longer the same. It's going to retrieve as the subsequent tensor objects or subsequent batch. Okay, instead of making use of next here, I'm going to enumerate this particular iterator, which is given as I comma a tuple of x and y. In enumerate data_iter here, So obviously I need to unpack this. You can always go about printing it simply so as to understand the index as well as X data as well as Y data. So now here we have read this too many number of times. Like every single print statement that gets executed is going to print 10 different observations per tensor. So this is the first index which is referenced by 0th index. Now you have 10 observations that are retrieved for X and 10 observations, the first 10 observations for Y. And here it's the subsequent tensor or the subsequent batch with this X data of 10 observations, with this Y data of 10 observations. If I'm changing this particular batch size to 20 or 11, now you no longer have 10 observations per batch, but rather you have 11 observations per batch. You scroll through all of this content that's printed out. Now you clearly understand that there are 11 observations rather than having 10 observations here. Let's also check the total number of observations or the total number of samples that are present within this particular data. So dataset.len is going to help us understand the total number of samples. The total number of samples here is going to be 506. So 506 divided by 11 is a batch size. Now there are going to be in total about 46 different iterations that it has gone through. You can simply create a particular variable called iterations, assign a value of 0 to this. I'm going to append the total, I'm going to append or whatever. I'm just going to write this update equation so as to understand the total number of iterations once the execution is complete. Okay, I need to rerun this whole statement so that now some data gets populated into iterations. So there are 46 total batches that are printed out, which is equivalent to the total number of samples that are present within the data and the batch size that we already have defined. So with this as a context, that we have understood the process in which how you can read the data, and we also have understood how you read the data in batches. Let's try to implement the SDD process or mini batch gradient descent process and try to leverage the PyTorch built-ins as much as possible in order to recreate the linear regression model. Okay, so that's pretty much all I wanted to discuss with you in this session. And thanks for watching.